Hi, my name is Jonathan Hsueh. I'm a first year CS major, and this is my application for the Fall 25 ULA class application for CS16 specifically, but it can be any other class too. And a little bit of background about me. I love teaching. Teaching's always been a part of my life. I always did like retreat leadership, tutoring, and I do sidetrack at UCSB. And I love being able to have a mentor role in people's life and being able to guide people through learning. And so I'm going to be talking today about recursion, which is a important topic in CS16. And a little bit about me here. Here's some photos of me. Here's my life. Here's basically it. Yeah. And yeah. So before we begin, I'm gonna tell you guys a little story. There once was a little rabbit who couldn't sleep, so its mom read it a story about a little fox who couldn't sleep as well. So its mom read it a story about a little weasel who couldn't sleep. So its mom read it a story about a little otter who finally fell asleep. And the little weasel fell asleep. And the little fox fell asleep. And the little rabbit fell asleep. Credit Professor Matney for this one. Uh, Introduction to stacks. Computers use a memory structure called stacks. They're similar to a stack of paper. To insert data, you push it onto the stack. You throw it on top, like this beautiful image right here. And to retrieve it, you pop it. You take it off the top, like you right here. You take the piece of paper off. And this uses a format called last in, first out. The last thing I put in is the first thing I'm going to access and take out. Yep. So during a recursive situation and some helpful information, uh, whenever you call a function, you create something called a stack frame, which is just an object on the stack right here. So A, B, C, they're all stack frames, and then these are just things that the program can run. So first, we get a recursive call. We call the function we're calling again, and then we usually change the parameters a bit. So then we add a new stack frame, and then we and then we with the new parameters, and then we keep going until it reaches a base case. Now, what's a base case, you might ask? A base case is almost like a kill switch. The recursion stops once you reach this case, usually by reaching a certain input value or parameter. If you don't, and the stack keeps growing, and then you just have a stack overflow, and you crash your computer. But anyways, you grab the top stack frame, you start where the execution was paused, and you finish it, and then you throw it away because you don't need it anymore. And you keep doing this until the stack is finally empty, and then you get your results. So yeah, it's pretty cool. And here's a little visual demonstration of it. So you start with your first call, you call this, and then you get the print, and you're like, oh, I'm calling it again. We're going to create a new stack frame, and we're going to stop at the print, and we're going to go make a new one. We're going to keep doing this, doing the exact same thing, check where the arrows are going, until we get to our base case. N is 0 now. So it's going to return, and then the next part, oh, we're done? Okay, we're going to continue after print. So we're going to do, oh, we're going to print it out. So we're going to print out 1 first, and then we print out 2, and we print out 3, and then that's how we get our result. 1, 2, 3 in that order. So let's do an example. We're going to reverse the string. Recursive functions can have any type of a return type. Ideally, if it's a void, it'll print or edit something. How do we use it to flip a string? Well, think recursion breaks up a problem into smaller parts, and if you put the recursive statement above the action statement, the last operation will always appear first. Okay, here we go. So we have our function, we have our base case. If it's 1, it returns, it ends it, stops the recursion, and it's return the recursion part first. So it's going to go all the way to the end, and then it's going to print that, and it's going to add, and then it's going to keep doing that until you get to the first value. So the first letter will appear last, and the last letter will appear first. So if I put pods, it will get swapped. It's pretty cool. Now let's do an example with powers. Recursive functions can also have multiple arguments that get edited. How do we raise a recursive function to find the value of x raised to the power n? Think recursion breaks up a problem into elementary steps. These are the elementary steps of exponents. This is for positive and this is for negative because of this. And then here are the steps. We have our base case, we have our positive and our negative case. And then these are basically multiplying the elementary step by the recursive call, and then you just keep doing it until you get your final result, and that's your answer. And yeah, here are to-dos. You want to finish assignment 6 and lab 7. It's going to be on. You guessed it, your favorite recursion. And to all the ULA graders and probably Professor Matney and anyone watching this around the time I made this, please just make sure have a great summer. Thank you. Bye.